Now that we've learned how to solve absolute value equations algebraically, let's look at some graphs of absolute value functions and then solve some equations graphically. The graph of an absolute value function always makes a V shape. As long as what's inside the absolute value is a linear function, meaning there's no x squareds. As soon as that happens, it gets even weirder. So what happens, let's just look at this first example. Solve absolute value of x equals 3. If I were to graph f of x equals absolute value of x, what happens is that half of it is the line y equals x, meaning a slope, and it starts at 0, 0 and goes up 1 over 1, slope of 1. But then the other half, when the x value is negative, the y flips to be a positive. So for the other half of the graph, we get y equals negative x, meaning it flips up because the negative x values become positive when we put it into this function. So now it's a slope with negative 1 down here. And so that's the idea of why these functions always make a V shape, is because the negative half of, if whatever's inside the absolute value is negative, it flips up to being positive. So the y values flip to positive values. So it's like if we continued this line over here, but then just flipped it upward. That's why these graphs are always a V. And remember, you can always use Desmos.com as well. Just type in those vertical lines on the keyboard. They're sort of near the enter sign right above it. But let's look at this graph. It's already made for us. So we see we have this y equals absolute value of x, which is like two lines put together to make a V. This tip of the V here is called the vertex, very much like a parabola. But we're solving for where the absolute value of x equals 3. So what is going on here is that we're graphing the two sides separately. So we have f of x equals absolute value of x, and maybe g of x equals 3. There's two separate functions that we're graphing, and we want to know where they're equal. So the intersection points where they're equal are negative 3 comma, not 0, negative 3 comma 3, the y value is 3, and then positive 3 comma 3. So the y values are 3 because that's the one of the functions we're crossing, and it's the x's that are the solutions. So our solution set to this equation are the x values negative 3 and positive 3. So the solutions are the x values. And the y value just is where the two functions, what that value equals. All right, let's try another one. Solve the absolute value of x minus 3 equals 4 graphically and algebraically. So let's start with graphically because we got the graph here. So it's another V shape. The slope is still 1, but what happened here, and normally we'd think of the minus 3 as maybe as like a y-intercept, but what it does if it's inside the absolute values, it moves left or right. So here we're starting at 0 or 3, 0 as the vertex. But what we want to know is where does this absolute function equal 4? So here's the horizontal line, y equals 4. There are two places where these graphs cross. So the two places are where x is negative 1 and where x is 7. The y value of these points just reflects that we're solving for where y equals 4, but it's the x values that are the solutions. Now, it also said algebraically, so this is a good way to show that we're going to get the same answers whichever way we do it. So algebraically, x minus 3 absolute value equals 4. Any absolute value equation, we have to split into a positive side and a negative side. There are always two sides to this absolute value. Either way, we're going to add 3 to both sides, so I get x equals 7. Add 3 to both sides, we get x is negative 1. Oh, and look, we get the same answer. So graphing is another good way to check an algebraic solution, especially when Desmos.com makes it pretty easy just to type it in and look at the 2 points. But remember, of course, we want to also see your work, especially when it comes test time. All right, last one. Here's one where we have 2 different absolute value equations, so 2 different V-shapes. And here, the x minus 6 in absolute value makes a V where the vertex is at 6. And the absolute value of 2x has an absolute value where the slope is 2. Notice it goes up 2 over 1, up 2 over 1. So what's inside the absolute value can change the shape of the V if we have a different slope multiplied by x. But what we're looking for is where these cross. So it's here and here. So the 2 points, we got 2, 4, and then negative 6, 12. But the solutions are just the x values. So graphically, the solutions are negative 6 and positive 2. And if we plugged those in, let's check. Yeah, it's a good way to sort of see what these y values are doing. So if I check, the absolute value of 2 times negative 6 would be the absolute value of negative 12, which is 12. On the other side, I'm seeing, does that equal the absolute value of negative 6 minus 6, which is also the absolute value of negative 12. So yeah, it checks out. I don't even need to evaluate that. Those are equal. Let me make it look like an absolute value though. There we go. If I check 2, I get absolute value of 2 times 2, which is absolute value of 4. And we want to know, does that equal? And then this would be absolute value of 2 minus 6. Absolute value of negative 4 equals 4. So yeah, 4 equals 4, that checks out. And notice the y values of these points are giving sort of the checking results. So that here the y values both equal 12 when x is negative 6. And in this one, the y values both equal 4 when x is 2. But it's the x's that we're calling the solutions. Now this one also asks for algebraically, so let's review how to do that. I have absolute value of 2x equals absolute value of x minus 6. We still split up into 2 halves. So I have 2x equals x minus 6, which is the same. Or we need to check that they could be opposites. 2x is negative x minus 6. So it's either that they're the same number or that they're opposite numbers, one positive and one negative. For the same, I'm going to subtract x from both sides, so that's x is negative 6. And that was the first solution we got up here. It works out. With this one, I have to distribute that negative sign. Just make sure you always do that with opposite. 2x is negative x plus 6. So I would add x to both sides. 3x equals 6 does make x equal 2. And that was the other solution. So algebraically and graphically should always give you the same answers. Graphically is a great alternate way to check if you're not into plugging in. So all 3 show that these are our 2 solutions.